It's coming back. Okay, so Control Alt Shift H. There we go. That's better. This seems to be like that. Okay, can everybody hear me? Yeah. Just wait a minute. Stop. So I'll be talking today about generating coin numbers with AI. I am Damien Wu. I'm a little disclaimer, I'm not an AI expert, just a software engineer. I've done some AI when I was young, that was available. But I just wanted to brush up my skills a little bit here, some experiments and have fun. And I thought you might be interested in seeing what I've done. I've created some images for my presentations here for stable diffusion. These images probably look better this year, but it's still fun to play with these things. So I'm going to talk about how I came up with the idea, what data I've been using, how to encode documents for AI learning. A little aside on finding similar documents with the TF-IDF method. And that's AI so that VuFind is using to find similar documents. And then we're going to look at the subject, creating document embodies with what2vec first and then doc2vec. And finding how to generate coin number classes and subclasses from API. Switch to a different option, which is to use only supervised learning to do everything. So I'll explain how it works and compare it with previous experiments. I will talk about trying to do the same thing, generate coin numbers with one, compare it, see how precise we are. And I'll talk about what I've learned this year, because I've done most of these things last year. But this year I worked on trying to enhance the data for processing, and we'll see how it went. And finally, I'll give some advice on machine learning, some lessons I've learned. And yeah, the code, if you're curious about it. So the idea is pretty simple. VuFind is using LCC call numbers to match our documents. Sorry, I've got this message here showing up on the screen. It's using LCC call numbers to match our documents for similarity when you choose the similar item tab. But some documents do not have a call number. Codes machine state. And we finally have a call number. So I was thinking, well, when the similarity must not work very well with these documents. I mean, there are factors with the coin number, but the coin number is the first one. So my idea was, could do similar items in VuFind by generating show call numbers for those documents that don't have any. So VuFind is extracting the class number from the call number to compare for similarity. And that's everything up until the dot. I wasn't thinking what I could generate all that class number. I was thinking I can just generate one class and one subclass and work through pretty well if I managed to do that. So I had to change things a little bit in VuFind so it can match some documents that have a call number with some that don't have one. And I thought, well, we can, instead of just taking the class number out of the call number, we can take different subsets of the call number. Just the first two letters, class and subclass. One with the class number, so everything up until the dot. The term number. So this way, documents that are very closely related, call number strongly matched with similar items. And the ones that are just remotely related, with just a class and subclass, will still have some kind of connection, even if it's not as strong. And this could find LLM, which should come out soon. We are waiting for it. So here what I've been is just generating the first two letters. I used the same data what VuFind is using for similar documents. So the title, topics, languages, formats, and then I've extracted some of our just to experience similar documents. So the column library, that's actually the print columns from the missions from 52E, which is from folio, and 50A for MCC members. And we also on similar documents, not to generate call numbers because it's not super format. And like I said, we've got records, LCC call numbers, and of the formulas, I've used 80% for training and 20% for testing. To use existing call numbers to train an AI model to generate fields. How do we do that? I take rows of numbers, also called vectors or embodies as inputs. I'm going to say embodies from the just think of it as an array of numbers. And so we need to create catalog records for each record. Aside the TF-IDF method, VuFind is using that to find similar documents. It's actually implemented in Solar. It offers a simple way to find similar items. This is just map, it's not AI. The VuFind fields are simply tokenized, so separated by and concatenated. Everything is put together in one text. When present, call numbers can be used in various ways. I've experimented looking for similar documents using the TF-IDF method, but changing the inputs a little bit compared to what VuFind does. So I tried, for instance, to turn call numbers into keywords or several parts. The TF-IDF is simply the term frequency multiplied by what's document frequency. So that gives a highway to where tokens open in the document. For instance, if you've got a particular word that's there in one of your documents, but it appears frequently in one particular document, that's going to be important to find similar documents. If there are other documents that are in the same case, they are going to be closely related. That method is very easy to use. It's good to find similar documents, but itself it does not generate. So we need to find another method for that. to be able to train a model. So the first method I've used to create document analytics was work-to-work. That's unsupervised. So it can be applied to all the documents to have examples with call numbers to use method. Work-to-work is used to work. There are two techniques. There's the continuous background word, which picks a target word from its context words. That means it's training the model to target word from the context. Skipgram is like the opposite. It predicts the context word and the target word. It's continuous background words. So I kept doing that. That is capturing semantic relationships between words, text, but generates embeddings for the tokens, so global words basically. And if we want to get embeddings for the documents, we still have to assemble these word embeddings. And it's not necessarily clear how to do that. So I've tried a few different methods in TF-IDF for the embeddings. But I ended up just summing the vectors. That's what worked the best. The truth vocabulary is limited. This model is not going to learn all the words in the documents. It's only going to work on the most common words that are found in documents. And one difficulty there is that it's easy to tell which words are effectively well, how to set the limit. Because you should set a limit to tokens that are learned it's going to try to focus on so it doesn't have a chance to work efficiently. It's not easy to decide to stop. It is a job at learning common words and semantic similarity. We've got these vectors, we can just look for similar vectors, a set of vectors, to look for similar documents right away. And it gives good results if we do that, but quite as good as the TF-IDF method. However, it's a pretty good method to generate document analytics. So once we've done that, we've got our analytics for the documents, all the documents. There is another method to generate directly for documents. It's called doc2work. It's also unsupervised. That extends work-to-work. It trains on text like it. It adds document and output. That the document and gets trained at the same time as the word analytics. That's pretty easy to use and generate the documents and it's right away. But I found that it doesn't work well with short texts. I was using just a title and format languages, this kind of thing. So I had very short text, and this document was coded that well compared to what I was getting by simply summing things with work-to-work. So I kept using work-to-work from then on. And use doc2work. Now I was to do these things with doc2work, I was using the GenC API. It's pretty easy to use, but I can't comment it because it's not, unfortunately. Then to generate numbers and subclasses, the supervised one will use the Keras API, which is outdated. So training the subset of the documents will have call numbers and testing the rest of them. I've used for classes and for each class to classify the subclasses. So I wasn't using the same model to run the classes and the subclasses. And I've used different layers inside that model. Started by something in sequence, dense layers. The dense layers are simply connecting all to put So it's classic neural network. And one basically for the output of the classes or subclasses. So that last layer has the same number of nodes as there are classes or subclasses in the class. And this gets a bit technical. I used optimizer for learning. I calculated the accuracy with sparse categorical accuracy method. It's not that simple actually to calculate the accuracy with that. But 10 epochs, what's the number of times you work with all the documents, training I've used batches of 512 documents. So basically that means at the same time. Can increase that if you got enough RAM to go faster, but you shouldn't go too far because that is the accuracy. So you have to be careful if you've got a lot of RAM skills. Not to go too far. And I reached an accuracy of 86%. That's the accuracy for just the classes. There's a different accuracy for subclasses, but it's similar. Just one reporting accuracy. To simplify things, I'm just talking about the classes. And, so the pre-calculated numbers done makes the learning, supervised learning faster. Basically, because I don't have to recalculate the numbers all the time, I just use these index and I focus on generating the core numbers. So I can do, I can quickly change the parameters here. Set 10 epochs. Obviously, I've done some experiments here. I found that if I go too far, it's going to affect to go well. If I do less, then I will get less accuracy. So I did some model tuning here, and having this pre-calculated number makes it easier. But I was thinking, could do everything with supervised learning, including the creation of new beliefs. And I was wondering how well if I would get better results. So I tried that. Can you see my cursor? Yeah, you can. So I've done Keras to do everything this time. So I basically added some levels to start right from the text. So I start from the text. Each token is given a different number. These numbers are turned into entities. So basically vectors. After that, I've tried different models here from bidirectional short-term memory model, which is a kind of working network that gets results. It takes a bit of processing compared to other methods, but I am going to through that. And was finally one for classification. I didn't actually put all the numbers here, so I did work out later to try to pull overfitting customize it as you want. I've tried some alternatives I've tried to the viral steam network, simple dense layers, as good the convolutions with results. I also tried the transform model, which is what LLMs are using, and what the results are. I'm not sure if I did something or if it's good for this kind of training. But basically, the latest one, text vectorization, still, yeah, the list tools. I've set a maximum to 50,000 maximum tokens, just like to work. If you try to learn to, it's not going to go well. So you have to set a limit. Setting it to 50,000 work. So I had to do some experiments to find that. I limited the sequence length, simply the length of the text, what you get to 512 characters. So that's also hard to choose, because if you do something that's too big, it's not going to focus enough on if it's too short, then you're going to miss information. So that's something to try, basically, to see how it goes. 5 epochs were enough with the BioSTM because conversion is fast. And I use different batch sizes for classes and for subclasses because I don't have the same number of documents in each case. For classes, I've got a lot more documents, which we're talking about subclasses. I only have the documents that are for this class. So I've used a smaller batch size to increase precision. And then I've tried to compare what maps. So I tried, so far the API I used the llama and the LLM was the llama. Just one because it gives a run because I wanted it to run on my computer and I wanted it to run fast because I've got millions of documents. To run that just run and simply, but it's going to be super slow. So if you want to use, you should use GPU and from to classify several items at a time to try to go faster, but you have to keep this question simple. Results are small batches, so you should ask for 50 coin numbers at the same time, like 10 or 20. With too many, it's confused and it runs out of time and will just use your random. Structuring the data, choose how to put title, topics, then ask to what call number help at least with one topic. Here's the prompt I used for number 3.1. Here's a collection of books. It's call number for each of them. Return only the call number for each entry, do not add any comment. And these LLMs skip adding comments. It's hard to tell them not to. I used a different prompt for Gemma 2, which I tried to was a collection of batch size books. Here I've had to add books to classify because if I sometimes give me results with less than 10. So well, expected help here. The rest is the same. Let's look at the results. Here's a typical one response. Here the number of converse columns for each books. Now I will text it easy to pass, but it's not too hard. Just one two points. So I was able to exert the parsing used to be about potential because the format things in the same way, which is not common. Parsing is pretty well compared to the 67% for LCC classes. It's moving the 2.1. Gemma 2 got to 65%. This was changed from one year to the next when I tried that last year. It was 2% less than that. So that was a tiny improvement, but I think they've put more efforts in one large language models. It's getting difficult, I don't know, but there's not much improvement from one to the next. On the right side, quite any training. Just skip to more column without any division right away. Yeah, as well. Text file to what reply and train the documents. We try to explicit classification for LCC classes. So basically, I try to describe the classes from A to Z and then give rough results. These LLMs have some notion of what the call number is. We understand the format, what are the different parts, and we can generate them. Well, besides the first two letters, it's often kind of random. And just looking at the first two letters, it's very good in terms of accuracy. This year, seeing the data, so there's an example called here. I'm going to move it a little bit. I've got the format title, which is some Chinese, translated Chinese, and some English from original. All in the title, I have information from this record. I have topics, for instance. This is typical from in HTML records. The idea was that LLMs are pretty good in English processing, so we can use them to translate this title into English to generate topics to help classification afterwards. That's a real idea, right? I'm not missing that. So here's an example of what I've used. Censored translator. I had to add uncensored, otherwise it would refuse to translate some titles. The good thing about running it locally is that I can put that in the system part. So I basically changed the focus of to get uncensored if I was trying to do it. Each title is converted into a JSON object, the complete title translated into English, a set of topics. Translate all titles into English, as well as repeat into English here. They're sometimes hard of hearing this. It helps to repeat things a little bit. Include the original title. I use original response. I see wishful thinking. I found it helps a little bit. Maybe I have seen it myself. I do add any comment. The value just error. Now, if you do that, it's going to try to some JSON that once in a while it's not going to be valid, and when you try to do it around the records, you to different time. So the trick here is to add the JSON schema for processing. You can define it's going to first basically to respect that schema when you give the answer. And that actually works pretty well, and it doesn't slow things down. So that's really the solution to trying to pass the response. You give it a JSON schema, it's going to use that. And put some French here, les espaces de pas pour vous, mutation pour l'été, 18e, 21e siècle. And some others. As an example of how to see what it was able to actually format that correctly in JSON schema. Translation is topics are okay. It basically works. Change the temperature of the model to keep it creative. If you don't make it creative at all, it's just going to copy things from the title. It's not going to be interesting. If you make it too creative, the topics are going to be from the subject, and that's not going to. I can just use the default hand. Try to actually apply that and see how it works. used 3.1, which we use for that. I ended up generating topics because it was too slow uh, to do file documents, and also it actually reduced the accuracy in the end. So I guess that was not extracting the topics from the title, I guess, and just generating them was too creative. I'm not sure, but that didn't help. And for translating titles, it was also too slow just using LLM. So that Argus Translate, which is also some AI, it's using OpenMT machine translation. But it has an API. It's out. So each model for Argus has been trained particularly uses intelligence using transforming models, just like LLMs. But they are actually 15 times faster than LLMs. Um, so it's much better for translations, which is to use supported, it doesn't support all languages. Data is coming from an open project. So what I did is that I used Argos when I couldn't return to which so like in example, so in this case I used as a backup. It's much slower. And in all our topics, that comparison was still well. Translations, it actually took me almost a week to process all these records. But then, if you work 10, 10 servers with virtual GPUs each, you can, I could. And accuracy was 0% better. So just marginally better. Um, um, I'm thinking so also don't have much other data like topics and what kind of languages. So seeing what I could get over was a little bit see. But still, so how can I interpret that? I'm saying my previous law was recognizing tokens in languages. But said I think I could make some on translations. These translations, well, it's more doesn't work well transliterated text. So I think if I do it again, I will try to uh, to do translations. I think I'll get more results. So these translations I could be used for some rules. I was thinking could VuFind search well translated titles and they will show up. I could then work those in other languages when we put text. That could be interesting. But I haven't actually some advice about machine learning. So sometimes learn the hard way. If you want to do similar experiments, you should know. First, don't use LLMs to process large amounts of data. It doesn't go well. It's just to unless you've got a lot of servers. LLMs are great to get answers for just one question, but the records, it's really slow. Then check if there's all to do. If you to generate call numbers and ask me for my model, I can just send it to you. You don't have to do all the training. You can just use the model and if you do want to do training, you should have a large data set, millions of records. If you just have thousands, you have time training the model. Check your data quality. It's very important at the end of the day that classification is only going to be as good as your data. If you can separate the data set. So what's recommended is to separate the data set into three subsets, training, validation, and test. I've just used two subsets, but there might be a bias calculate the accuracy because I'm optimizing my model with what I'm using for tests. So I could have done something better to lower the accuracy correctly and use two different subsets. If you care about the precision of the accuracy, that's what you should do. You should shuffle your data first. Initially, I just documents in the lower database. And the results were not as good as we could because there was some bias because it was in the order that books had been entered in the catalog and it wasn't quite easy. So my advice is to shuffle your data so that what documents are from training. Use a GPU, TPU, or NPU because you need the processing power. And if you need AI, the batch size, I talked about it a little bit. If you can use a larger batch size to increase performance, but what can also reduce accuracy. So you need to test that, see what it is before training the batch size. Most of the time, I would say use only supervised learning. I got better results by using only supervised learning. By the exception, where if you don't have a ton of documents, you might actually better results with supervised method first, because then you want to same way. So if you don't have user document, try unsupervised to create models and supervised to do calculation. As you train the model, check when it's the evaluation data set at the same time as the training one. So what I recommend is to just check every time at every step. So at each epoch, you check the results so that you know when it's fitting the data. Keep a log of all the parameters and results optimism models, otherwise you're going to do something. Yeah, in the end, keep in mind what's more like cooking science. I can also, with Keras, the Keras API, I can also compare it to, because you've got these different blocks that you can assemble, these different levels. You can play with one, see what works best. Well, 30 years ago, you had to implement everything. It's fun. Experiments, but it's really much easier to do. And finally, if you're curious about it's not super high quality code, it was just for experiments, but the results similar items, and well, that's noticeable. Generated coin numbers. Is there any question? Yes.
Make use of the semantic difference between the titles and the topics. And I'm curious, would
Uh, Sorry, I'm distracted here. Can you say it?
Whether you could represent the semantic difference between the title and the topic by actually assigning different values to the words in those fields during the vectorization stage. With that,
Semantic difference between topic um, election. So what I've done is I'm just concatenating everything. So I can I guess we could process the titles and topics separately, get different vectors, and we still have to combine them. Actually, just because the topic has have a restricted vocabulary, I guess you could possibly train the model topics and then to combine that with the rest and not sure how to best develop assemble vectors, I suppose. Really not sure what results you would get from that. I think we should just explain and talk about it. Yes.
I was wondering what you used to check for accuracy, how you went about that process.
Check for accuracy. I've explained. Get back to the slide here. Is it?
What was your measuring? What did you consider accurate in the first place?
Yeah, I used that sparse category called accuracy. Which I didn't write. Someone's moving. It's a classification problem. Different possible outputs and classes. And for this kind of problem, accuracy is well suited. Well, particularly. Yes.
correctly, correct me if I'm not, is the idea that you held back a set of your records with known call numbers so that you could then run them through the neural network and confirm that the result the neural network generated matched the actual result you already knew you wanted.
That's exactly. Yeah, I've used a set of documents, call numbers, run that generate call numbers and basically as training points, I'm making sure that the ways to generate the right class and subclass for the document, which I already know because those are documents which have a class and subclass. So basically, I'm using the existing classification to train the model. Then, at the end of the day, still two documents that don't have a class number, a call number, and generate these actual call numbers. See if we've got any questions on Zoom. Someone commenting sometimes coding that. So, yes.
So I understand you said there was 86% accuracy on predicting the class, and then you said a similar percentage for the subclass.
Yeah.
And then I'm guessing for the cutter, again, a similar percentage.
I didn't go as far as trying to generate the cutter. That was already hard enough to do class and subclass. But I do it in the future, you know.
I'm just trying to figure out, because you said you had this in production, and I'm just trying to figure out how you made that transition. If the process gives you a good answer 86% of the time, how do you deal with the other 15? You know, are you manually generating it? Can you tell? I mean, you don't know when it's good and when it's not good without manual review all of them, right? So how were you able to operationalize this into production?
So when I a document to the model to generate the code, it's going to be good one. So it's going to be good one. And since I'm going to by hand. However, I do get confidence percentage when you do it. That's what's an advantage of this method. So what I've done for production is I've checked the confidence. If it's below certain threshold, I don't use that code number. I don't add it to the document. But that being said, there's still going to be errors, right? Every once in a while, it's going to give a call number that will be completely off. What I can tell, because I've looked at the results, is well, generally that improves the results for similar documents. But I know also sometimes it's going to make it worse.
Well, I'm just sorry, following up on that, like the risk of it with a similar document recommendation is not so good. Like, okay, if you have a bad call number guess, bad recommendation, not as big a problem as if you're actually displaying the call number and someone is using it for some other canonical.
Exactly. Displays generated call numbers without them. So, you know, it's not too bad if it's wrong. It's not going to have too much of an impact. It's just going to, you know, change the similar items mainly. And I was thinking also, you know, if I wanted to display these translated titles, we would have to make sure to generated translations. I would have to be careful with that, obviously. Yes.
So the whole point of this was really you probably said that's debating, to generate better relationships within VuFind, not to identify the location of the code.
Similar items you find. I mean, you could find another usage for this generated call numbers, I'm sure. So let me know if you've got some other ideas. I just thought, yeah, but because similar items are mostly based on code for that. And the good thing also is once code numbers have been generated, I keep using them. You don't have to try and plan events. You can just use what's been generated. Yes.
Better on Google generates this when it hasn't been generated, you've got to test the test collector. How much better is it? Identifying similarities. Have you got an estimator of how good it was ultimately in finding similar documents?
That's a good question. I measure precisely. I did, so this is something I would. I'm looking at a bunch of records, trying to estimate the similarity was better areas.
Generally was, but
so I found that generally it was better. With some mistakes. Generally, I didn't says automatically because information. I didn't have someone general that does it for me, unfortunately. And that's something that could be done in the future. Yeah, student to when the gods will do it. I don't have the the question well, so if you want. Okay, I guess thank you.
Yeah.
I'll stop the recording.
You're using this for